So now let's look at another type of problem. What volume in liters of a 6 molar solution of hydrochloric acid is required to get 0.200 moles of hydrochloric acid? So pause this video, and once you get an answer, start it again and we'll review it. So the first thing I always do is I write out what I'm given. And whenever I'm given a molarity, I want to write that as moles per liter. That will help me keep track of how units cancel out. So I'm given 6.00 moles per liter of HCl, 0.200 moles of HCl, and I want a volume in liters. So if I look at the equations that I have, the three equations I can use to solve molarity problems, liters is equal mole per molarity. So 0.200 moles HCl for 6.00 moles per liter. My moles of HCl cancel out. My units end up being liters. And I'm going to express my answer in 3 sig figs. 0.200 divided by 6 is a repeating decimal. So I'm going to round it to 3 sig figs, 0.033 liters. Now, just for fun, I changed it to milliliters here, but the question did not require that. I just did it because I just like to do that kind of thing. All right, let's look at another problem. How many moles of sodium chloride are in a 65.00 milliliters of a 0.250 molar solution? So pause the video and see what you get, and when you get an answer, resume and we'll go over it. Okay, so I always start out writing clearly what I'm given. I'm given 65.00 milliliters of solution. I'm given 0.250 moles per liter of sodium chloride. That's my molarity. When a solution is molar, that's its molarity. And I want moles of NaCl. So I look at my three equations and I realize that this is the equation I need to use. Moles equals molarity times volume in liters. Now the only thing is, I don't have liters, I have milliliters. So I must convert my volume to liters before I can plug it into this equation. So I multiply 65 milliliters by the conversion factor 1 liter per 1,000 milliliters. My units of milliliters cancel out, and I end up with 0.06500 liters. So then, once I get my liters, 0.06500 liters, I can solve for moles, because moles is molarity times liters. Now again, I want to break down my units of molarity into moles per liter. So 0.250 moles per liter of sodium chloride times 0.06500 liters. My liters divided by liters cancel out, and my calculator gives me this value, 0.01625 moles of sodium chloride. I'm going to express it with correct sig figs. I have 4 sig figs here, 3 sig figs here. My final answer should have 3 sig figs. So if you got this as your answer, give yourself a pat on the back. Okay, we just did this one. Okay, so this one's going to be our most challenging one so far. So it may take you a little bit longer to solve. That's okay. Give yourself enough time to really think about it. What mass of sodium bromide is required to make 250.0 milliliters of a 0.109 molar solution? So work on this, and when you get an answer, start the video again and we'll review it. So the first thing I do is clearly label what I am given. 250.0 milliliters, 0.109 moles per liter of sodium bromide. This liter is over here, it's not directly under the mole, so sorry, that might be a little bit confusing. And we want mass. Well, how do we solve for mass? Mass is nowhere in any of our three equations for molarity. What I can solve for is moles, because moles is molarity times volume. Even though I'm given milliliters, I can convert that to liters. So I can solve for moles. So once we get moles, how do we get to mass? Molar mass. So let's take this one step at a time. The first thing that I need to do is I need to convert my milliliters to liters so I can plug it in to this molarity equation. So I multiply. Alright, so when I multiply 250 milliliters by the conversion factor of 1 liter per 1,000 milliliters, my milliliters cancel out, and I end up with my volume now in unit of liters. So now I can plug in to this equation here. So my moles of sodium bromide are going to be my molarity, 0.109 moles per liter, multiplied by my volume in liters, 0.2500 liters. My units of liters cancel out, and I end up with units of moles of sodium bromide, and the value that my calculator gives me is 0.02725. Okay, great. Now, I'm almost there. I just have got to convert my moles to grams. So we know the conversion factor between moles and grams is molar mass. So over here in this corner, I've calculated the molar mass. To calculate the molar mass, we need a periodic table, and we need the formula. So if I look on the periodic table, I see that 1 mole of sodium has a mass of 22.99 grams, and 1 mole of bromine has a mass of 79.90 grams. I add those two together, and I get 102.89 grams as the molar mass of sodium bromide. 1 mole of sodium bromide is equal to 102.89 grams. Now I can convert from moles to mass. So I start out with my given of the moles of sodium bromide, and I multiply it by the conversion factor of molar mass. So if I have moles in my numerator, I need moles in my denominator here, so they'll cancel out, and the mass of a mole goes in the numerator. I multiply across, the value I get is 2.80. I'm going to stay with 3 sig figs since this molarity has 3 sig figs, and that's the smallest number of sig figs given in this problem. So if you got this, you did great. If you got only halfway there, that's okay. You'll get lots of practice with your homework, and good job.